Hi, this is a video lecture for Chapter 4 in lieu of class because of the weather. So let's talk about why it is that we want to normalize. So Chapter 3, we constructed exclusively normalized tables. And in Chapter 5, we're going to be dealing only with normalized tables. In real life, this isn't necessarily always going to be the case. Some people may not have taken this class or a class like it, and will thus not create tables that are ordered and ideal for our purposes. So this leads to what we call anomalies. These are discussed in the book, and because this isn't something that we're going to be dealing with as far as an experiential exercise, I will leave that to you to read in the book. So for the exam, what I'm going to want you to do is first take a non-normalized table. I'm going to want you to identify the normal form of that table, identify the dependencies, and especially the problematic ones. When we say problematic dependencies, what we mean are the partial key dependencies and transitive dependencies. A full key dependency is not problematic, and in fact, a full key dependency is what we're going for. Once you've identified all those dependencies, we want to convert the table to third normal form, which is going to mean adding additional tables. Finally, there may be an extra credit question on the test that will have you draw a relational schema for the tables as they exist. So let's give an example of what we're looking for and what you're going to see on the exam. So I'm going to treat this in the way that I will any other class, which is to say that rather than lecturing about the PowerPoint deck, I'm going to give you a number of examples, exercises. I will have you pause because it's video, and then after you work on that, then we will reconvene, or I'll continue the video, and thus we can discuss what exactly we need to do to normalize this table. So let's get started. So this is an example of a non-normalized table. And so the first thing that we want to do is identify the normal form. Now, identifying between the first normal form and a non-normalized or a zero normal form table does this meet the definition of our relations, which is to say, are rows unique, are columns defined, and then most importantly, do cells have only one value within them? Typically, the most common violation of the first normal form is going to be that a cell includes multiple values. So you can see here that we don't have multiple values in any cells, and thus we can conclude that this is at minimum the first normal form. The second normal form, the prerequisite for that is first that it's in the first normal form, but that it doesn't include what we call partial key dependencies. And so we want every column to be dependent on the entire key of the table. And so you can see that the key in this table, which are underlined, is add campaign ID and mode ID. Those jointly are the key. And so what we want to see is, are there any columns that are dependent on only add campaign ID and not mode ID, or only mode ID and not add campaign ID? So let's start by looking at add campaign ID. And so I see add campaign ID 111 has an ad campaign name, Summer Fun 13. The next row has ad campaign ID 111, also has Summer Fun 13. Ad campaign 222, Summer Sing 13. The next two rows also back that up. Ad campaign ID 333, Fall Ball 13, and so on. Now, if you look at mode ID and ad campaign name, then mode ID doesn't seem to have any relation to ad campaign name. And so ad campaign name is dependent on ad campaign ID, because every time we see ad campaign ID 111, we see the same ad campaign name. Every time we see ad campaign 222, we see the same campaign name, and so on. So ad campaign ID 111 stands in for Summer Fun 13. Now, mode ID 1 seems to have nothing to do with the ad campaign, or with ad campaign Summer Fun 13, because you can see mode ID 1 is associated with Summer Fun 13, but then mode ID 1 appears again, and the ad campaign name is Summer Sing 13. So if you think about this in terms of a student database, if you had, so your name would be dependent on your student ID. Now, your name wouldn't be dependent on a class ID that you're taking. even though they may wind up in the same table if it's non-normalized. So mode ID does appear to be related to mode ID 1, let's say, seems to be local TV. And then we look at mode ID 1 again, we have local TV or TV local. If we look at mode ID 3, we have local radio and local radio and local radio. And then we don't have any other repeating mode IDs as I can see them. So what I'm going to do is I'm going to keep looking through the various columns and try to link them to a table. Now, something that you might expect is that I'm not looking to make this any more confusing than it needs to be. And so it should, the names of the columns should roughly match up with what you might expect. But don't rely on that for the exam. So according to my analysis of this table, I see that ad campaign ID determines ad campaign name, start date, duration, campaign manager ID, and campaign manager name. Mode ID determines media and range. Now, neither of them individually determine budget percentage. And so if no if no key individually determines a column, then that means both keys or both components of the key jointly will determine that column. So budget percentage, in other words, is a function of both ad campaign ID and mode ID. In other words, the ad campaign ID and mode ID have a relationship that's M-to-N, that an ad campaign may have multiple modes and a mode may have multiple ad campaigns, and a budget percentage is an attribute of that relationship. Now, so ad campaign ID and mode ID indicate that we have partial key dependencies, which is to say that there are some columns that are dependent on part of the key, but not the entire key. And so an example of this is ad campaign name, start date, duration, and so on, up until mode ID, are dependent on ad campaign ID, but not mode ID. And then media and range are dependent on mode ID, but not ad campaign ID. So ad campaign ID and mode ID are jointly the primary key. Remember, you can only have one primary key. And budget percentage is dependent on both ad campaign ID and mode ID, which is to say that budget percentage is full key dependent. So having a full key dependency is fine, but having a partial key dependency, such as ad campaign name, that is dependent on ad campaign ID but not mode ID is a problem, because that's going to lead to anomalies. And so namely, if we wanted to revise the name Summer Fun 13, or let's say extend the duration from 12 days to 15 days, and we'd need to make two update operations rather than a single one. Whereas if we had this table normalized, there'd only be one column, or one row that had Summer Fun 13 ad campaign ID 111 in it, and we could update the duration field there, and then that would propagate through all of our tables because they'd be linked up through foreign keys. Now, campaign manager ID is a somewhat special case because campaign manager ID is not a key. Rather, campaign manager ID appears to determine the campaign manager name. So Roberta is campaign manager CM100, Sue campaign manager 101, and so on. But you can see that Roberta is also managing ad campaign 555. And so the campaign manager is determined by the ad campaign, which is to say an ad campaign manager is associated with an ad campaign. But because the campaign manager ID is not a key, this isn't going to be a partial key dependency. Rather, what this is going to be is a transitive dependency, or a dependency that does not rely on a key itself, but does rely on another column. So the way that we're going to list our dependencies is using this format. So we're going to have, for example, campaign manager ID, arrow to the right, campaign manager name. So what that says is campaign manager ID determines campaign manager name, or alternatively, campaign manager name depends on campaign manager ID. Same with mode ID, determines media in range or media in range depend on mode ID. And then we can go down the list. Now, this is more than we need to include because we have a couple of what we call trivial dependencies. And so, for example, we don't need to include the fact that ad campaign name and mode ID, we don't need to include that ad campaign name determines these various columns because ad campaign name is itself dependent on ad campaign ID. And because that's the case, we can just say that anything that is dependent on ad campaign name is by definition dependent on ad campaign ID. So again, I think that this is something that you want to consider the names of the columns and how they relate. So once we remove all of our trivial dependencies, this is what we're left with. Now this is from the book, and you can see their rationale for why they removed the various dependencies, or you can talk to me or the TAs after class. The streamlined sets of dependencies are what we're going to prefer to see on the exam. So one way you might want to think about this is, what would the ER diagram look like that would create a dependency list like this? And so you can see that the ad campaign is has a campaign ID, a campaign name, a campaign start date, and campaign duration. And then it also has a manager. Now, because there's one manager per campaign, but a manager can manage a number of campaigns, the foreign key is going to wind up in that ad campaign table. Mode has a mode ID, it has a medium, and has a range. And those are dependent on the mode entity itself. And then the budget percentage is going to be a function of the relationship between ad campaign and mode. So I don't want you to think about this too much, especially on the exam, but you can see that if you converted this ER diagram to a relational schema, that it would already be normalized, and we wouldn't have it all go into one table. We would have 3 separate tables, or I should say 4 separate tables because of the end-to-end relationship. And so that is going to automatically give us a third normal form. So now that we've discussed why and what we're doing, let's work a few examples out. Now, what I'm going to have you do in this and every example in this slide deck is to identify the normal form, list the dependencies, which is going to include all problematic dependencies, and then you're going to want to normalize it into the third normal form. Finally, I'm going to create a relational schema out of this. So I'm going to pause for a second and let you pause this video. Go ahead and work out those various questions, and then we will reconvene. Okay, so first, I think a good first step is to identify what the key is. And so in this case, we identify the key by looking at what is underlined. And so we can see that account ID and account holder ID are the key. So let's look at account ID and what that determines. So the keys will never determine each other, and you can say that pretty simply. Now, having said that, let's look at account ID 111. That looks like it is always checking. Looks like that account has the same current balance and the same interest rate. So let's look at account 333 because we have some duplicates on that one. That is always a money market with $15,000 and a 1.5% interest rate. Account 444 similarly has is a savings account type, has a balance of $3,000 and 2% interest rate. Now, just logically speaking, we can infer that account type, the current balance, and the interest rate are probably features of the account ID. Now, the account holder, or the account holder name, let's say, is not necessarily dependent on account ID, because in this case, Joe Smith and Sue Smith are both named on account ID 111. Now, at the same time, they do have separate account holder IDs. And so we can see that account holder ID always determines the account holder name, Joe Smith. When we look down at A444, account 444, we can see that Joe Smith and Sue Smith also have their names associated there. Now, C333, 444, 555, and 666, now they don't repeat, and so they are not going to be useful for determining what the for determining dependencies. Now, neither account ID nor account holder ID seem to have anything to do with the date that somebody was added to the account. So we can see account ID A111 and the date account added is different. A444, same thing. A333, same thing. Now, at the same time, remember that because neither key individually determines, or neither component of the key individually determines the date added to account, that means that both components of the key jointly must, in fact, determine that. And so that is going to be a full key dependency. Now, finally, it looks like the interest rate and the account type might have something to do with each other. Now, conceptually, I think that this makes some sense. A checking account is going to have the same interest rate, generally speaking. Same with money market, same with savings. These are going to be advertised by the bank, and so we can say that the interest rate is in fact determined by the account type as well. Now, that doesn't mean that the interest rate isn't also determined by account ID, and account type isn't itself determined by account ID. But rather, this is implying that there's a transitive dependency between the interest rate and the account type. Now, in order to normalize this table, we would need to take a couple of steps. First, let's remember what the normal forms are. So the first normal form is any table, or schema I should say, that has tables that meet the rules that we have defined for relations. And so most importantly, that means that that all cells have exactly one value in them. So this table already meets that. Now the second normal form is the first normal form, so it needs to already meet the first normal form, and it has no partial key dependencies. And so this is going to require 3 separate tables. So what we're trying to do is disentangle the partial key dependencies. So account ID, current balance, interest rate are all dependent on account ID. Account holder name is dependent on account holder ID. And then our third table is date added to account, which is going to be dependent on both account ID and account holder ID. Now, let's remember the third normal form is any table or schema that meets the second normal form, which is to say it doesn't have any partial key dependencies. And when we say that it meets the second normal form, we're implying that it also meets the first normal form because the second normal form builds on the first normal form. The third normal form, rather, takes a second normal form schema and removes all transitive dependencies. And so in this case, there is a transitive dependency of interest rate on account type. Or in other words, account type determines interest rate. And so we would create another table yet, a fourth table, that has the account type and the interest rate. Now, because we have the interest rate pulled out on the account type, that means that we would have the first table that has account ID, account type, and current balance. A second table that has account holder ID and account holder name. A third table that has account ID and account holder name, account holder ID, and the date added to account. And then we'd have a fourth table that's account type and interest rate. And so in this case, you can imagine that if we wanted to increase the interest rate on the money market account from 1.5% to 1.75%, that this way we would have that single row that has the interest rate for the money market account, and we could just change that 1.5 to 1.75, rather than in this table where we would need to change 1.5 to 1.75 in several different places and run the risk of of making an error and having one or more rows be incorrect. And so, and here I'm using the relational schema to avoid having to recreate the tables. This is also a fine way of doing it. Now, so to reiterate this, we have 4 sets of dependencies. And it's not an accident that 4 sets of dependencies leads to 4 tables. Rather, in a tidied up dependency list, the number of dependency sets is going to determine the number of tables you have. So we have these 4 dependencies: that account ID and account holder ID determine date added. That account ID determines account balance and account type. That account holder ID determines account holder name. And that account type determines the interest. Now, it would be a trivial dependency, for example, to include interest in account ID. So account ID would not include account balance, account type, and interest, because account type itself determines interest. And so that way we don't need to say that, because it's already implied by the set of dependencies that we have. So now that we've discussed this, I'm going to cut this video here. I will, what I'm going to do is solve at least one, probably a couple more problems in separate videos, so that you don't need to scrub through a single video to find all these. So once again, if you have any questions about this, please don't hesitate to come find me, or hopefully you can watch this video again. So I will see you in class for review on Tuesday.